Hello, lazy chemists, and welcome to today's lecture, which is about balancing chemical equations. And today's lecture is a really important one for us because it helps us to go ahead and determine the ratio that different products come together. And more importantly, I think that this lesson and this section and the kind of work that we get to do here is actually a little bit more fun and engaging than some of the other sections where we have to, end up doing math or adding and doing arithmetic. Nobody really wants to do that. But today, what we're going to do is we're going to balance chemical equations. And our whole goal here is to make sure that at the end of the day that we have the same amount of material on one side of a chemical equation as we have on the other side, okay? So the basics are that in a chemical reaction, atoms and their masses are always conserved. So you guys have heard before that matter can't be created or destroyed, okay? Only transformed. Well, what we're going to do is we're only going to transform it from one compound to another. And that means that there should be the same number of atoms on each side of an equation for each element, okay? All right. So that's using our conservation of matter. And lastly, we have our balanced equation, an equation in which the number of atoms of each element as a reactant, left side of the arrow, is equal to the number of atoms of that element as a product on the right side. Okay? So this right here, this is our first kind of equation here. And we're going to go ahead and copy all of that. We're going to get rid of that for now. All right. And this equation here, it has a couple of sides to it. The first side we have are our reactants. Okay. And this is the side that's on this left side of this arrow. And our last thing are our products. Okay. Okay. And then this arrow, what this arrow does is it says, hey, we have H2O and oxygen coming together to make or reacts with. And this arrow just shows that we have a reaction happening here. Okay. So, what we're going to go ahead and do is we're going to see if this reaction is balanced, and how we're going to do that is we're going to go ahead and write our elements here, and we're going to start with H here, and we're going to put oxygen at the bottom. And we have a reason for doing that I'll get into later. But we're going to go ahead and count. So this is a lecture period where we need to be able to count. So if you have trouble counting, well, unfortunately, you're going to have a hard time. Okay? So over here on this left side, you should notice that, hey, this says H2, okay? So I'm going to guess that we have 2 hydrogens on the left. Over here on this side, or let's go oxygen next. On this side, we have 2 oxygens as well. All right, so this should make sense. H2, there's 2 hydrogens. O2, there's 2 oxygens. On this side, hey, hydrogen, it looks like we have 2 of them. That's great. That's working out just fine because on the left we had 2, on the right we got 2. It's working out well. But then oxygen, oxygen, we have an issue. Okay? There's only 1 oxygen over here. Oh, that's not good. Okay? So, is this equation balanced? Our answer to this is going to end up being no. Okay? It's saying that, hey, somewhere along the line, we took 2 hydrogens and 2 oxygens, and an oxygen disappeared, okay? We don't want oxygens to disappear. That's bad, okay? So, we're going to have to balance it. So we're going to go over the ways that we are going to balance it. And the way that we're going to balance it is we're going to put a coefficient in front of either the reactants or products. Now, a coefficient is the only way that we could change a compound. So if we go back here, if we tried to put a 2 here instead of something else, what we would end up doing is making hydrogen peroxide. Okay? Now, water is safe to drink. Hydrogen peroxide is not safe to drink. Hydrogen peroxide is that things that you sometimes put on cuts, and it's theoretically supposed to help disinfect. Long story short, it doesn't, and you should stop using it for that. But hydrogen peroxide is a very different chemical than water, okay? So that means that our coefficients that we're going to use to balance this are not going to be in the formula. And we cannot change the subscripts of the formula, okay? So we can't do something like this, and we can't remove an oxygen because that's not how it works in nature. Instead, what we're going to do is we're going to put numbers in front. And these numbers in front are going to help us to balance this equation out. Now notice we can go ahead and do the math right here. Here we have 2 times 2, so we have 4 hydrogens here. We have 2 oxygens, okay? Because we didn't write the 1, and you guys already know why, okay? Here we have 2 hydrogens, and now we have 2 oxygens. So now we have a balanced equation because we have the same amount of compounds on both sides, okay? Now, the steps, what we're going to do is we're going to go ahead and list the elements. We're going to count the atoms of each element on each side of the elements. We're going to determine the coefficients that will create equal number of each element on both sides. And then we're going to go ahead and double check. So we're going to multiply through and double check. This is going to end up being a trial and error process. You are going to want to use a pencil, all right? The more you practice, the better you're going to get at this. This is another one of those things where it is a lot easier to cheat and try and balance it out using Google. However, once you get good at it, getting good at it is going to make you faster than trying to type the equation into Google. Some helpful hints, all right? So these are some tactics that, we use to solve it here. Okay. The 2-3 rule. If the count of an element is 2 on one side and 6 on the other, you're probably going to need to make that element 6. All right? And that's because that's the only way that 2 and 6 can get to a common final denominator. You want to save any single elements that you have for last because those are going to be your easiest to balance. If there is a polyatomic ion that is the same on both sides, you're going to want to keep that together. If you have hydroxide on only one side, it might be easier for you to go ahead and change water to be HOH, okay? This is a really big one here, okay? That it saves so much time to go ahead and think about water like that instead of, water. Okay, and then the last one is be extra careful when you see an element that shows up twice on one side. Okay, and we'll have an example here. Often combustion products end up having that. And I have one extra one for you. Usually try and balance oxygen last. Oxygen's a wily element, so you need to be careful with that one, because he is a trickster. Okay, so let's go ahead and do this one here. This is chlorine coming together with sodium bromine to make bromine gas and sodium chloride. Okay, step 1, listing our elements. Count. So 2 chlorines, 1 sodium, 1 bromine. 1 chlorine on the right, 1 sodium on the right, 2 bromines on the right. Okay. Determine coefficients to balance. Okay. So this fixes the sodiums and also fixes the chlorines. Or it fixes the chlorines first. And then because we break the chlorines, we have to balance out the sodiums and the bromines. And that balances it out. Okay? Okay, so this one's another type here. Notice this is one where we're going to get to be able to use our 2 and 3 rule because chlorine here has 3, this side has 2. We list the elements out. We count them on both sides. Here, we knew that this chlorine, we likely had to make it so that chlorine equaled 6. That's why we put 2 here. We put 3 here. That 3 goes to both the magnesium and the chlorine. 6 here. This will also change our aluminum. Then we have to change our magnesium and our aluminum. Okay, it's a trial and error type thing until we get to an equation that is perfectly balanced. Notice we have 3 magnesium on both sides, 2 aluminum on both sides, and 6 chlorines on both sides. Okay, so this is another example. I want you to notice here that here we had our polyatomic ions. Okay, it is completely possible for you to break these apart and make S and O and H separate things. Okay, but that is not lazy, and we need to be lazy. So if you see polyatomic ions and they're the same on one side as they are on the other, keep them together because that is what you need to do. If they change, then you can break them apart, but only if they change. If they're stuck in their prison on both sides, keep them in their prison. Okay. All right. So this time we balance the Fe first because it's up on top. I made 6 OHs. Okay. Notice 2 and 3, so we likely have to get it to 6. 3 to balance out the OHs, which changes our calciums. We have to balance out the calciums, which then balance out, which messes with our SO4s, and it happens to fix our SO4s. Okay? And now we're balanced. Okay? This one shows us a new type here. Now notice, this one has our water. And what did we say we wanted to do with our water? We wanted to put it into H and OH. Alright? So, this is essentially saying the exact same thing here. Then we want to break it into H and OH, okay? Trust me, this is the lazy way. Oh, well, you were supposed to do that. All right. Now this one, this is one of my favorite types, okay? These are combustion. I love giving combustion questions, okay? Notice that the oxygen is on both sides, okay? One of the reasons that we want to keep oxygen for last as our balance is because it's going to multiple things. So it's easier to balance it out if we only have to balance it once instead of like 4 times. Okay, so I'm going to give you time to go ahead and try and solve it now. I'm going to wait 5 seconds. Pause the video if you want to try and balance it out now. And for those that just want to watch the show, you would end up balancing out the carbons first. Okay, 5. And then you'd be like, hey, wait, there's 12, so 6 times 2 equals 12. And then at the end, you'd balance out the oxygens. Okay? So that's the general process for balancing out equations. You should be able to start working on the worksheet for balancing equations now. And I hope that you're able to see the process and see why. And hopefully you can have a little bit of a fun, because this one is kind of just like a little bit of a puzzle that you have to go ahead and solve. You're just trying to balance them out, make sure everything's nice and even. Okay? Until next time, remember, stay lazy, my friends.